In this lesson, we are going to investigate natural base E. And so I'm going to use calculator to do that investigation. So the first step is that you have to copy and complete the table by entering the value of 1 plus 1 over x whole raised to power x into the table for each x. So the value of x which we have to fill out in this table is 1, 2, 3, 4, 5 and then powers of 10. And then we need to give the answer to correct 5 decimal places. So I'm going to use calculator to do that. So first thing is we need to enter y is equal to, the function is 1 plus 1 over x to the power of x. So 1 plus and then alpha y. And then you have 1 divided by x, close the bracket, and then to the power of x. Now we need the value 1, 2, 3, 4, 5. So first thing I need to set the table. So second window, and set your table at 1, and let's increase the table values by 1 as well. And then I will go to second graph. So these are the values which we get for and let's change the values in decimal. So let me change mode into decimal here. So this one is function okay here. So auto decimal. And now I'm going to go back to the table. So I got the values in decimal. I'm going to record these values. So we got 2, 2.25, 2.3704, 2.4414, 2.4883. And now we need to find the values when x is 10. So I'm going to go back and change the setting into start table by 10, and then I'm also going to do this 10. I might have to change the table start for 10, 100, and 1000 and so on. So I'm going to go to, again for the when x is 10, you got the value 2.5937, and I can see the value for 100 also, 2.7048. Now I'm going to do the same step. So going to second table set, and now I'm going to have this as 1000. And then you go to second table. So for 1000 we got 2.7169, and now I'm going to change it to 10,000, and then again go to second table, and you can see 2.7181, and then again you go to set the table 1 to 100,000. And then again you go to, sorry, we didn't need to go to graph. So we need to go to again second graph. So second table. And then you get 2.7183. Now if you keep on increasing the powers of 10, then you will see that the number, if you notice from 1000, the number, the first 3 digits are 2.71. And so 2.71 here, 2.718. So this is what you are getting here. Okay, so you can continue with this thing, and you can see that the number still will be, the first 3 digits is going to be 2.71 here. Okay, so now we have to graph this using a technology. Again, I'm going to use GDC, and the domain is between 0 to 10. So I already input the function. So I'm going to change my window setting, which is 0 to 10, and x scale is 1, and y minimum is 0, y maximum is 5. So I'm going to go to graph, and the graph of this function looks like this. So the graph of this function is going to look like something like that. Okay, now if you look at this, if we have to approximate the asymptote here, so asymptote is a line where the graph is approaching but is never going to touch. So if you look at this thing, you can see here 1, 2 and 3. So the asymptote seems to be closer to 3. So I'm going to go back to the table, and from table values you can see the values were 2.7183. So the asymptote is going to be near to that number. Even though you change the value of increase the power of 10, the values are going to be very, very close to this number. So which means the asymptote in this case is going to be y is equal to something 2.718, approximately near to that. Now again, you can see this from the graph, because the graph is going to be somewhere, the asymptote will be like this. And the same thing you can see from the table also. We use the table to actually find out this value, but you can also see from the graph. If you look at this, this is 1, 2 and 3, and this is the limitation of the screen, because if you will use any other technology like Desmos, then you can see this graph. You can zoom in, zoom out, and then you can see that very clearly. And then using the table also, the value of 1 plus 1 over x to the power of x, limit x approaches to infinity, is going to be 2.718. Okay, so this is called, this has a special name. It's E, which is the Euler's number, and the value of E is approximately 2.718. Okay.